Hello, chemistry students. I wanted to make this video in order to review how to balance chemical equations in preparation for your quiz tomorrow. What we have here is a chemical equation where we have a reactant that is breaking apart into two products. Now, in order for a chemical reaction to be viable, it has to follow the law of the conservation of mass, which means that the number of atoms of each element on the reactant side has to equal the number of atoms of each element on the product side. So that's what we do when we balance equations. We add coefficients to the beginnings of compounds in order to balance them out. And what happens is something that is just like the distributive property in algebra. For instance, if you have 4 times x plus 3, the 4 is going to multiply times x and also times 3 to give you 4x plus 12. Well, if I put a 4 in front of KCl, for instance, then this would mean that the 4 is going to distribute to each element, to the potassium as well as to the chlorine. So I would have 4 potassium and 4 chlorine. So that's kind of the principle that we are dealing with here whenever we balance equations. So in order to get going, what I am first going to do is draw a line where the arrow is, just to split up my reactants from my products, and I'm going to list the elements that I have on each side of the arrow. So here on my reactant side, I have 1K, I have 1 chlorine, and I've got 3 oxygens. So not only am I going to list those, but I'm also going to write down how many of each I have. And then over on this side, I have 1K, I have 1 Cl, and I have 2 O's. So as you can see, the amount of potassium is the same on each side of the arrow. The amount of chlorine is the same on each side, but my oxygens are different. So that's where I need to start with my balancing. Now I notice that I have a 3 and a 2. Well, when I have two numbers that don't readily divide into one another, what I want to do is find the least common multiple. So I'm going to take 3, multiply it by 2, and I get 6. How does that help me? Well, that means that I'm going to try and get 6 oxygens on each side by adding coefficients in front of the oxygens. So let's start over here on my product side. I've got 2 oxygens. I want 6 because 3 times 2 is 6. So I'm going to write a 3 as a coefficient here in front of this compound O2. That means that now I've changed from having 2 oxygen atoms to having 6. On the other side, I've got 3 oxygen atoms. Well, I can't just squeeze a 2 in there in the middle. That is not allowed in chemistry. What I have to do is put my 2 at the front of the compound. But just like I showed you before, that not only changes my O, but it's going to change my potassium and my Cl as well. So 2 times 1 potassium gives me 2 potassiums. 2 times 1 chlorine gives me 2 chlorines. And 2 times 3 oxygens gives me 6 oxygens. Great. But now my potassiums are unequal and so are my chlorines. So the best way for me to even this out would be to put a 2 as a coefficient here in front of KCl. So the 2 is going to distribute to my potassium, giving me 2 of those now on the product side. But it's also going to distribute to my chlorine, which is going to give me 2 chlorines on my product side as well. And look, I've got 2 potassiums on each side, 2 chlorines on each side, I've got 2 oxygens on each side. This is now a balanced equation. So what I want you to do now is to try and balance this one on your own. So hit pause, go get a pen and a piece of paper, and see what you can do to balance this before I go on. Okay, so let's take a look here. The way that I would balance this, I'm going to change my color here to purple, is I would draw my line here, list my elements. I have 1 S on the reactant side, and I have 2 O's here. I have 1 S on the product side, and I have 3 O's. And look at, we have the same scenario. 2 oxygens on one side, 3 on another. What's the least common multiple? 3 times 2 is 6. So I want to try and get 6 oxygens on each side of that arrow. So to do that, I've got 3 on my product side, so I'm going to start by putting a 2 there, right in front of sulfur trioxide. When I do that, that gives me 2 sulfurs and 6 oxygens. Over here on the other side, to get 6 oxygens, I'm going to put a 3 there. And 3 times this 2 is 6. And then over here, in order to get 2 sulfurs, I'm just going to put a 2 there as a coefficient for sulfur. And that changes this. So there we have it. 2 sulfurs on each side, 6 oxygens on each side. This also is a balanced equation. This equation is a little bit more complicated. We have polyatomic ions that are here. And the first thing that I'm going to say about the polyatomics is that it makes the equation look more complicated, but really it doesn't make it too bad. If you take a look, I have a nitrate on each side of the arrow. So instead of writing my elements as magnesium, nitrogen, oxygen, and so on, I'm going to keep my nitrate together and treat it as if it was a single element. And take a look. I also have PO4 on each side. So I'm not going to separate the phosphorus from the oxygens. No, I'm going to treat that as a single element and keep it together. So I also have potassium, and then of course I have my PO4. On the other side of my arrow, I have the very same elements. And now I have to go through and count them. On the reactant side, I have 1 magnesium. I have 2. Well, that was silly. I have 2 nitrates. I have 3 potassiums, and I have 1 PO4. So notice that in this equation, this PO4 is not in parentheses. That means that we only have 1 of them, whereas this nitrate is in parentheses, and we have a 2 on the outside. That means that we've got more than 1 of that polyatomic ion. So let's take a look at what we have on the other side. I have 3 magnesiums because that's what the subscript tells me. I have only 1 NO3. I have 1 potassium, and I have 2 PO4s because that's what that little subscript outside of the parentheses is telling me. So as I take a look here, I'm just going to start with my magnesiums because they're at the top of the list and they're obviously not matching. So for magnesium, I'm going to place a 3 over on this side. That's going to give me 3 magnesiums, so that now my magnesiums are even. But then remember, this 3 is going to distribute to the NO3. But I'm not going to multiply it by the NO3, by the 3 in NO3. Rather, I am going to multiply it by the subscript outside of it. So that means I now have 6 nitrates. Okay, so let's look at the other side now. I've got 6 nitrates on my reactant side. I'm going to want to try and get 6 nitrates on my product side. In order for that to happen, I have to look for my nitrate. It's right here next to the K. I'm going to put a 6 there. I only have 1 nitrate, so 6 times 1 is 6. Oh, whoops, I forgot to put my 3 over on that other side. But this 6 is also going to distribute to that potassium. So that means that I have 6 potassiums on the product side as well. But if I look, my potassium on the reactant side is only 3. So I'm going to put a 2 here for the coefficient. And in doing that, I have 2 times 3 is 6 potassiums. And the 2 is going to distribute to my phosphate, which is PO4, which means that I have 2 of those now as well. Oh, and look, I'm balanced. 3 magnesiums on each side, 6 nitrates on each side, 6 potassiums on each side, and 2 phosphates on each side. This is now a balanced equation. And this is the last example that I'm going to do for you tonight. And this one is a little bit tricky, but it involves a trick to kind of help you. So you're going to solve it in the same fashion. Go ahead and list the elements that you have. So we have sodium, hydrogen, and oxygen. And then if you look over here, we also have sodium, hydrogen, and oxygen. But this one is a little bit different. On one side, we have H2O. And on the other side, we have hydrogen and hydroxide. Well, in order to make this balancing a little bit easier, what we're going to do, and you can only do this with water, is we're going to rewrite water. We're going to change it from H2O to HOH. And we haven't changed the water, we've just rearranged the components of water. So here's what that's going to do. It's going to take away that O, and instead we're going to put the polyatomic ion OH there. So let's take a look at how many we have. We have 1 sodium, 1 hydrogen, 1 hydroxide, and on this side we have 1 sodium, 2 hydrogens, and we have 1 hydroxide. So this right here is the 1 hydroxide that I'm talking about. Okay, so in order to get just 2 hydrogens, because that's the only one that is unbalanced at this point, I am going to draw a 2 for the coefficient here. And that means I now have 2 hydrogens and I have 2 hydroxides. But now on the other side, I also need 2 hydroxides. I'm going to put a 2 here as my coefficient. And that distributes to the sodium as well as to the hydroxide. So now to balance sodium, I'm going to put a 2 here in front of Na, or sodium, and that means I now have 2 sodiums. And if you look, 2 sodiums on each side of the arrow, 2 hydrogens, and 2 hydroxides. This is now a balanced equation. So remember that sometimes it's easier to take a look at the whole equation. If you have water on one side of the arrow and you have hydroxide and hydrogen on the other, rewrite that water so that it's HOH. It may help you balance more efficiently. I want to give a shout out to Anthony and Michael in period 10. Have a great night. Study well for your quiz.